Assalamualaikum, and we are going to present about high performance liquid chromatography, also known as HPLC. These are our group members. Chromatography is a technique used to separate and identify the component of a mixture. Works by allowing the molecule present in the mixture to distribute themselves between a mobile and a stationary phase. Components that are strongly retained by the stationary phase move slowly with the flow of mobile phase. In contrast, components that are weakly held by the stationary phase travel rapidly or fast. As a consequence of this different immobility, sample components separate into discrete bands that can be analyzed qualitatively and or quantitatively. High-performance liquid chromatography, also known as Hplc, is one of the types of chromatography. It is a powerful technique for separating the different components in a mixture. Analytes are first dissolved in a solvent and then forced through the column under high pressure. HPLC is very versatile because of its ability to easily separate a wide variety of chemical mixtures, which include non-volatile and thermally unstable compounds. Advantage of HPLC are greater sensitivity because it has various detectors. It ideal for ionic species and large molecules.
Let's move into method of HPLC. Firstly, it's the sample preparation. Sample preparation, which the sample must be prepared for analysis and making sure the sample are in the right form. Then, the prepared sample is injected into HPLC. Column, which is the crucial component in HPLC, because to identify and measure the amount of different things in sample. As the sample travels through the column, components interact differently with the stationary phase and leading to their separation. The detector monitors will detect the eluent coming out of the column and generates a concentration of different analytes. Lastly, the data obtained from the detector.
Alright, so now let's look into this figure, the first figure, which is the graph of the amount of the caffeine in the standard caffeine. So we put the standard caffeine into HPLC test, and we found out that the retention time of the caffeine present in the standard caffeine is at 2.482 minutes. So basically, we will use this value to determine in the next sample, we have another two sample to determine whether we have the presence of caffeine in that sample or not. Alright, so let's move on into the second figure, which we have the graph of the amount of caffeine in the cooked sample. So if you look here, there are a few peak in this sample. We have like 7 or 8 peak in this graph, but we have a one of the highest peak, which has a retention time of the 2.481 minute, which this determine that they are the presence of caffeine in the sample of cook. Why? Because in the previous video that we see before, the caffeine eluted in the standard caffeine is 2.482. So basically it has the same range value of the retention time, so we can say that they are the present of the caffeine in this sample of cook. Alright, so for the next figure we have here is the graph of the amount of caffeine in the libido. So basically we have a few peak that came out in the sample. Based on the peak that we observe here, which peak that we're gonna take as the presence of the caffeine in the sample. So basically we take the closest value of the peak that are close to the value of the caffeine in the standard caffeine. So basically, we have the highest peak here, which is the 2.019, and also the second highest, which is the 2.479 and 9. So, which one between these two value is the peak of the caffeine present in the standard caffeine? So basically, the peak that are represent of the caffeine in this sample is basically the second highest peak, which is the 2.47 and 9 minutes. So if we look into the graph, we have to make sure that which peak or which value that we gonna take is the value that are the closest with the compound that we are observing, which is the caffeine. So here is 2.479 is the peak or the value of the caffeine present in the Levita sample. Alright, so next we look into the table that we have here is they are the retention time and also the period of the keeping. So basically, we run the HPLC with the three different sample, which we have the KPM standard, the code sample, and also the beta sample. And then it came up with the three value for the retention time, which we have the 2.482 for the KPM standard, and then we have 2.481 retention time for the code sample and also the 2.479 retention time for the beta sample. So based on this value, we can say that they have a same range value for the retention time, which indicate that they have the same presence of the compound, which we look here is the presence of caffeine. And then the next is the peak area of the caffeine, which we have the peak area of the caffeine for the caffeine standard is 6249.48779, and then the Cook sample, the peak area of the Cook sample is 7001.12305, and then lastly the peak area of the caffeine for the beta sample is the 1.11511 times 10 exponent 4. So from the peak area itself, later in the discussion, we will look into what are the significance or the peak area of the caffeine into determine the concentration of the caffeine in each sample of the sample that we run into the HPLC test.
Assalamualaikum, my name is Muhammad Faiz. So today we're going to discuss the result of this experiment. So the retention time for caffeine standard is 2.482 minutes. For Coke sample is 2.481 minutes and the beta sample is 2.479 minutes. So we can see that the retention time for Coke and the beta samples are close to the caffeine standard, which indicates the presence of uh, caffeine in the samples. In order to find the concentration of caffeine in the samples, we have to uh, divide the peak area by retention factor. In order to find the retention factor, we have to divide the peak area of caffeine standard by its concentration, which is 0.1 milligram per milliliter or 100 parts per million. So the retention factor is 62.4949, and then we get the concentration of caffeine in Coke is 112.027 parts per million, and concentration in Libita is 1.783 times 10 to the negative 6 times parts per million.
Okay, now let's answer a past year question that related to HPLC together. This question is from July 2022, question 4. The first question is, question A is, HPLC is an advanced form of column chromatography where the solvent is forced through the column at very high pressure of up to 400 atmospheres. This makes the whole process much faster, but also allows you to use a much smaller particle size in the column. Establish the advantages. Okay, for the answer, actually HPLC offers few advantages. The first one is increased speed. The high pressure in HPLC allows for faster separation of compounds compared to traditional column chromatography methods. This results in quicker analysis time, making HPLC a time-efficient technique. The second one is enhanced resolution. The use of smaller particle sizes in the column, made possible by the high pressure, leads to improved resolution of closely related compounds. This results in better peak separation and more accurate identification of components in the sample. The third one is improved sensitivity. HPLC systems can be equipped with various detectors that offer greater sensitivity in detecting and
quantifying analytes. This is particularly beneficial when analyzing trace amounts of compounds in complex mixtures. Fourth, versatility. Hplc is versatile and can separate a wide range of compounds, including non-volatile and thermally unstable substances. This versatility makes it suitable for analyzing diverse sample types such as organic compounds, inorganic species, biological samples, polymers, and more. Fifth, sample recovery. Hplc systems can be integrated with fraction collectors, allowing for the collection and recovery of separated sample components. This feature is useful for further analysis or downstream processing of specific compounds. The last one is reusable columns. Hplc columns can be used for multiple analysis, providing cost savings and convenience. This reusability feature is advantageous for laboratories conducting routine analysis. In summary, the high pressure and advanced capabilities of Hplc result in faster analysis, improved resolution, enhanced sensitivity, versatility in sample analysis, sample recovery options, and cost-saving column reuse, making it a powerful tool in analytical chemistry. For the question B, the condition of normal phase Hplc and reverse phase Hplc is described in Table 3. Identify 1 and 2. Based on the table, 1 refers to the nature of the solute in reverse phase Hplc and 2 refers to the nature of the mobile phase in normal phase Hplc. 1 is reverse phase solute. In reverse phase Hplc, the stationary phase is nonpolar. So, nonpolar solutes interact strongly with it and are retained longer. Thus, 1 is equal to nonpolar. For the second one is normal phase of mobile phase. In normal phase Hplc, the stationary phase is polar. So, the mobile phase must be nonpolar to create a differential interaction. Thus, second is equal to nonpolar. Okay, for the third question, the question is arginine, phenylalanine, and atrazine compounds are shown in figure 3. They are to be separated via reverse phase Hplc. Explain the reason why atrazine should not be analyzed using this method. Okay, for the answer is atrazine is a non-polar compound. In reverse phase Hplc, the stationary phase is non-polar and the mobile phase is polar. Non-polar compounds like atrazine would have strong interactions with the non-polar stationary phase, leading to very long retention times or even non-elution. This makes reverse phase Hplc unsuitable for separating highly nonpolar compounds like atrazine. Okay, now we move to the question D, which is last question. The question is, in the above mentioned Hplc analysis, predict the outcome. Arginine is a polar compound due to its amino and guanidino groups. In reverse phase Hplc, it will have weaker interactions with the non-polar stationary phase and will elute relatively early. The second one is phenylalanine. Phenylalanine is moderately polar due to its amino acid structure with a non-polar benzyl side chain. It will elute after arginine but before anthracene. The last one is anthracene. Anthracene is highly nonpolar and will strongly interact with the nonpolar stationary phase, resulting in very late elution or possibly no elution within a reasonable time frame. For the order of elution, the first one will be arginine, which is most polar. The second one is phenylalanine, moderately polar, and the last one is atrazine, non-polar, might not elute.
Now we have come to the conclusion part of HPLC. So HPLC is not only used in the experiments, it's only widely used in different industries such as the pharmaceutical, food and forensic science industry. As for the pharmaceutical industry, HPLC is used to confirm the identity of a drug and provide the quantitative analysis. Next, in the food industry, HPLC is used to analyze the sugar composition of a food product. Lastly, HPLC helps in identifying the illicit drugs, poisons, and the alcohol levels in forensic science industry.